Hello, Algebra 2 students. This is Mr. Myers, and I'm doing a screencastify today to talk about the difference between odd and even functions. The first one I'm going to start with an odd function. As you can see right here on my screen, I have a potential of an odd function. And why I say a potential for an odd function is because on this function right here, the highest power is an odd power. But just because the highest power is an odd power doesn't necessarily guarantee you that you're going to get an odd function. To be an odd function, you have to have reflectiveness over the y-axis, and it must go through the origin. So when I click on this one, you can see that this one does not go through the origin right there. It is above the origin, and so even though it has the appearance of an odd function, because it doesn't go through the origin, it is not an odd function. Now, I have a slider on C, so if I move the constant down to 0, now I do have an odd function because I do have this reflectiveness through over the y-axis through the origin. So when you are testing for odd or even functions, the easiest one to do is an odd function, and there is an algebraic test to it. I'm not going to show that to you today. The easiest way to test for an odd function is to go ahead and graph it in Desmos and then check to see if that has, first of all, reflectiveness over the y-axis, and also it goes to the origin. Okay, so that is the odd function. Even functions are actually a little easier to deal with because they have reflection over the x-axis, and the test, the algebraic test, is very simple. So here's an even function. First of all, I know it has a potential of being an even function because our highest power is an even number. Remember, if this is an even number, you don't have to test for an odd function. You only have to test for an even function. Okay, so even functions have reflectiveness over the x-axis, and I will show you a reflection here. You see these two functions are the exact same function because all I did was take the g of x, take h of x and make it equal to the negative g of x. And then look at my points here. And this is the algebraic test for reflectiveness. When you look at their points, if you put in an x into either function, and you essentially get the same answers except your y values are opposite. In other words, if I put in an x in both functions, the same x in both functions, so you can see I put in negative 0.577, and I get opposite answers for every point of the graph, I have an even function. That's the reflectiveness over the x-axis. So you can clearly see that both functions, g of x and h of x, are even functions, and they have reflectiveness over the x-axis. I hope that helped. If you want to test for evenness on the Desmos, that's what you do. First of all, you would graph it, and then once you graph it, make a second graph. And you could call it h of x, g of x, whatever you want to call it, and make the second graph equal to the first graph with the leading coefficient negative. That's all you have to do is change the leading coefficient to negative and see if it reflects over the x-axis. See if their points all line up with the y's being opposites. If they do, you've got an even function. If not, it's neither. I hope that helps. Good luck on your assessment, and we will talk to you real soon.